So my name is Bhavendra. Today I will be taking your physics class. The topic that we are going to do today will be electrostatics. Although you have already written one test on that, but again there will be a cumulative test for the three topics, that is electrostatics without capacitor, then electrostatics with capacitor, and current electricity. That will be after 2 weeks from now, right? You must have checked the test schedule, right? Very good. So today our topic is electrostatics. I will start slowly so that I can understand how well engaged you are with the class, right? And accordingly, I will increase the temperature and it will be adjusted. Today, the temperature will be very low. So try to be little fast in responding. Okay? Am I clear? Yes. Okay. So first we understand the concept of charge. What is charge? Intrinsic property. Intrinsic property of the charge. So what is the intrinsic property of the matter other than charge? Mass, right? So what is the fundamental of the two, mass or charge? Mass is the fundamental, right? That is why it is considered one of the 7 fundamental physical quantities. Charge is the state of matter. Do you understand it? Although we say that it is the intrinsic property, but basically it is the state of matter. Okay? But generally we define it as the physical property of the charge. And because of this physical property, the particle is able to exert and experience electrostatic force on each other. There is no need of writing the notes. Whenever we are doing the question, there you pay the attention. It is just to brush up the idea, right? So what do you see here in this diagram? There are two like charges. One is the positive charge, other is the negative charge. And when the two charges are unlike, they have a force of attraction. And what do you see here? There are two like charges and both are positive. There will be a force of repulsion. So the electrostatic force is due to the property that is called the charge. So now there are very simple questions based on it. Yes, can you answer it? Unlike charges will attract each other. Similarly, what type of charges repel each other? So which option will be correct? B for bravo. Okay? Very good. C for? Okay. Now, how do we define the Coulomb? Because whenever we are trying to measure the charge, we have to measure it numerically also. The SI unit is called Coulomb, but Coulomb is, as I told, not a fundamental quantity. Current is a fundamental quantity. So in 1 second, if 1 ampere current is flowing through the conductor, then it will conduct an amount of charge equal to 1. But the fundamental unit is what? The electronic unit. That is 1.602 into 10 to the power minus 19. Although it is not a universal constant, the universal constant is Faraday's constant, 96500 Coulomb per mole. That is the fundamental constant. But for our calculation purpose, it is considered to be a universal constant. And I hope you understand, according to quantization principle, Q is equal to N into E. So N will be Q divided by E. So in order to hold a 1 Coulomb of charge, how many electrons do we need? Approximately 6.28 into 10 raised to the power 18. But this is a large unit of charge. So what are the smaller units that we use? We use picocoulombs. How much is 1 picocoulomb? 10 to the power minus 12 coulomb. We use nanocoulomb. How much is 1 nanocoulomb? 10 to the power minus 9 coulomb. Then microcoulomb. What is 1 microcoulomb? 10 to the power minus 6 coulomb. We also use millicoulomb. How much is millicoulomb? 10 to the power minus 3. Okay. So can you state what the conservation of charge principle tells us? For isolated system. What do we mean by the isolated system? It is not gaining any charge from external source. It is not losing any charge. Okay. And primarily, if I have an isolated system and there are two particles, A and B, A is holding a charge Q1, B is holding a charge Q2. So what will be the total initial charge? Q1 plus Q2. And if they are allowed to exchange the charges, what will happen? Now A will hold a charge of Q1 dash, B will hold a charge of Q2 dash, and total final charge will be how much? Q1 dash plus Q2 dash. And according to conservation of charge principle, Q1 plus Q2 will be equal to Q1 dash plus Q2 dash. Is that clear? Because the total sum of the charge remains constant. Okay. When a glass rod is rubbed with a silk, what type of charge it will acquire? It will acquire positive charge because it loses electrons, right? When the glass rod has lost the electrons, it has number of protons more than the number of electrons because it has lost the electrons, right? So the number of electrons that has been lost will be acquired by the silk according to conservation of charge principle, correct? And for silk, number of electron will be greater than number of protons. So silk will become what type of charge? So which answer will be correct? Option B will be. Is that clear? Now we have the classification of material. So based on the electrical property, it can be classified as conductor, insulator, and semiconductor, right? What is a conductor? Material through which the charge flows easily, right? Primarily, the conductors will have free electrons. That is why they are called conductors. So the examples can be metals are good conductors. Now, what do we see in this diagram here? If the conductor is given a positive charge, that charge will get uniformly distributed on its surface, right? Because of the electrostatic repulsion, even if I keep the charge only in one part, in this part only if I provide the charge cannot stay localized, right? The charge has to get distributed throughout the surface and it has to acquire a uniformly charged, correct? But on the other hand, if there is a charged body and if I bring another charged body close to it, you know, there is a charging by induction. Because of that, there will be non-uniform distribution of the charges. Is that clear? So if there is a negatively charged rod that I bring here, what it will do? It will accumulate more amount of positive charge on this side where it has been brought, and other side there will be less. In that case, it will be a non-uniform distribution of charge. Okay. Then we have insulator. Primarily, insulators do not have any free electron. Because of that, they cannot conduct electricity, but in some rare circumstances, they can allow a small charge conduction. Is that clear? So silk, cotton threads, rubber, and many plastic goods will be insulators. So in this case, we see that if I'm giving charge to an insulator, then the charge will remain localized because it does not have the free electron. So there's no possibility of the charge to move and get distributed on the surface. Do you understand the primary difference, right? So sometimes when we look at the diagram, then we have to understand what type of material it is. Now we have the semiconductor material. In that case, the property lies in between conductors and insulators, right? So in semiconductor, there are few free electrons and atoms with bound electrons are also there, right? So both types of atoms are there. Okay. Example, germanium, silicon, gallium, arsenic, all these are the examples. When you look at this diagram, what do you notice? Conductor has all the atoms with the free electrons, meaning that when a potential difference is applied, it will obey the Ohm's law and it will have I directly proportional to V. In the case of insulator, you can see there is no current, I will be 0. In the case of insulator, there will be a small current, but it will not obey the Ohm's law, right? So it has both types of atoms. It has the atoms with free electrons, it has the atom with a bound electron. That is why semiconductor is considered lying in between the conductor and insulator. Okay. Now the process of electrification, you understand, there are three methods. One is by friction, other is by conduction, third is by induction. Now this friction method is available for insulators. Conduction and induction is available for conductors. Do you understand it? Right? So whenever we are talking about charging by friction, I'm talking about the charging of an insulator object, because by conduction and induction I cannot give charge to the insulators, I can give charge only to the conductors. Is that clear? So in the case of friction, what will happen? They will acquire equal and opposite charges, and after rubbing two insulators, they will start attracting each other. Okay, try this question. When a glass rod is rubbed with silk, then what type of method it is? So which option is correct? Okay. When a charged object is touched to an uncharged object, then what type of method it is? Which option is correct? It is touched. When it is touched, it has to be conduction, right? When it is brought close, then it is induction. Is that clear? So in the case of induction, physical contact is not required. In the case of friction and conduction, physical contact is required. So option C will be correct. When a positively charged body is brought close to uncharged body, in this case, what is the method? It is induction. Okay. Now I hope all of you have seen the Coulomb's law of force. F is given by 1 by 4 pi epsilon naught Q1 Q2 by R square. What is epsilon naught? It is the permittivity of air or the free space. Value is 8.85 into 10 to the power minus 12. Unit is what? Coulomb square per Newton meter square. I hope you can see it. Q1 and Q2 will have Coulomb each, so it will become Coulomb square. Force will have a unit of Newton, so Newton will come here. R square will become meter square. So it will be 8.85 into 10 to the power minus 12 Coulomb square per Newton. Okay, but in numericals we have to use 1 by 4 pi epsilon naught, so it will be 9 into 10 to the power 9. Okay, now this is the Coulomb's law in the vector form. This you can note down. What do we notice here? There are two charges, Q1 and Q2. Q1 is at a position vector R1. R1 you can see can be written as x1i plus y1j, and Q2 is placed at a position vector R2 that can be written as x2i plus y2j, and R21 is the position vector of charge 2 with respect to charge 1, so that will be R2 minus R1. That can be written like this, and this will be the. Is there any doubt so far?
No, sir.
No, sir.
No, sir.
Very. I'll call the name of the students. Those who are absent, sorry, those who are present can say I'm present. Adi Sinha is there? Adi Sinha? Abhijit? Ameya Wankhede?
Present, sir.
Diya? Harsh? Hiba? Hiba Muhammad? Kameshwaran?
Yes, sir. Kamesh present.
Lohit? Lohit Datta? Rohit? Roshna? Samir? Samir Ahmad?
Present, sir.
Syamal Dwivedi? Syamal Dwivedi? Sultan,
Present, sir.
Tejasvi, Tejasvi, Krishna Mitra,
Yes, sir.
Alan, Amita Shaji,
Present, sir.
Annapurni,
Present, sir.
Anvi,
Present, sir.
Ardra,
Present, sir.
Darshini Perumal, Divyadarshini,
Present, sir.
Isha,
Present, sir.
Harini,
Present, sir.
Krishna,
Present, sir.
Nuha,
Present, sir.
Pranav,
Present, sir.
Rejoina,
Present, sir.
Saba,
Present, sir.
Sai Shri Vaishnavi,
Present, sir.
Sai Shriya,
Present, sir.
Shakti Shri Devi, Shreya Satish,
Yes, sir.
Siddharth Sunil,
Yes, sir.
Syed Arsh. I'll call the name of absentees. Adi Sinha, Hiba Muhammad,
Sir, I'm there.
Hiba.
Yes, sir. I
Okay,
joined late.
no problem. Lohit Datta, Rohit, Shyamal Dwivedi, Tejasvi, Dadshini Perumal, Shakti Shri Devi, Syed Arsh, okay, have you written it? Okay, let us see how we can use it in the question. Bolo bache.
So it was like taking this K1 question vector R21 divided by modulus cube, right? We're taking the cube system.
Q. Because we have taken R square, the proportionality is for square. So because we have already taken one R here, so we are multiplying it by R cube. If I want to write in the unit vector, then we'll write R square, and here I will write R21 unit vector, whatever in the direction. Because R21 itself can be written as mod of R21 into R21 unit vector, right? So generally in the book, it is written in terms of unit vector. But there is double calculation. We have to do a single calculation because we are preparing for the MCQ type exam. Do you understand it? So our approach should be directly towards the solution. Okay. So this I have taken only two coordinates, x2 minus x1, y2 minus y1. But if there are three coordinates, x1, y1, z1, x2, y2, z2, that will be x2 minus x1i plus y2 minus y1j plus z2 minus z1. Okay. Do you understand it? Yes? Very good. Now,
Yes.
if the charges are not kept in vacuum, but they are kept in some medium, then what will happen? Instead of writing epsilon naught, we'll write epsilon. What is epsilon? It is the permittivity of the given medium. That is epsilon naught into epsilon r. Correct? Now, epsilon r is what? It is the relative permittivity of the given medium. Sometimes it is also called capital K, that is dielectric constant of the given. Is that clear? Right? Now, if we compare the distance between the charges when they are kept in vacuum and the distance between the charges when they are kept at a distance r in a given medium, the questions come where what they will ask, they will say that the two charges are kept at a distance r in a given medium. Suppose in water, the two charges are kept at a distance r. So by how much distance they have to be kept, or at how much distance they have to be kept if they are kept in vacuum? Then this is the shortcut for that. You can write it. R dash effective means R dash effective in air or R dash effective in vacuum will be R into root of epsilon, and vice versa. Do you understand it? If I know the distance in air, then I have to multiply that, divide that by root k to get the value of distance in the given. Is that clear? In this relation, R represents when they are separated in a given medium. R and R effective is when they are kept in the vacuum. Do you understand it? Any doubt is there to anyone? Okay. Sometimes the question is asked when the medium is partially filled by the dielectric medium, right? So earlier we discussed the case when it was completely in air or completely in a dielectric medium. Now it is possible that this is the charge Q1, this is the charge Q2, the total distance between them is R, but out of that there is a thickness T which is occupied by the dielectric medium of constant K. Do you understand it? So in this case we use this formula. You can write it and you can make the diagram also. Do you understand the difference? This is the partial filling of the space. Earlier it was the completely occupied.
So here also, if you like taking it as air, then we have to use the previous formula, right?
If it is air, then the value of permittivity will be 1 and this T and T will get cancelled and it will be the usual formula Q1 Q2 by 4 pi epsilon naught R square.
Okay, got it.
Do you understand?
Yes, sir.
Sir, what does T represent in the formula?
T represents the uh, thickness of the dielectric slab that is present between the two charges. R is the total distance between the charges and T is the thickness of the region that is occupied by the dielectric medium. Is it clear?
Yes, sir.
Wait. Okay. So can you answer this question? Coulomb's law is true only for what type of charges? It is only valid for static charges, right? When the charge is moving, then we have to use the Lorentz equation. You must have seen it in the chapter magnetism. Again, this is a direct question. Which option will be correct? Which option will be correct? Option C will be correct. Any doubt? In this case, what will happen? Yeah? Option D. Okay? I hope all of you are comfortable. Yes? It's not a heavy burden on your mind. The transition is easy. Now the temperature can be a little bit increased. Yes? Very good. Let us see. This is also a very simple question only, but it requires calculation. We have to find the force between two copper spheres, each of mass 1 gram, separated by distance of 1 meter. If the charge of them differ by 1% of the total charge, means the total charge held inside the nucleus, you can say, okay, or the total charge held by the electrons, anything you can consider, right? We have to find the force of interaction. Now I hope you won't ask what is the atomic number of copper and what is the atomic mass of the copper. 63.54 is the mass. Okay, and atomic number is 29. So first, please calculate how much charge they will hold, and then try to find what is the force of interaction. Is the question clear to all of you, or any problem is there? Means one will be positive, other will be negative. That is only then the force will be there. No? If there are two spheres, if both of them are neutral, how they will apply force on each other? Positive also, but here it is 1% difference. Means if one is 1% more, other is 1% less. Yes. Means the value of charge will be same as compared to the neutral state. If it is 1% more, then it will become positive. If it is 1% less, then it will become negative. If you remove the electron, certain number of electrons from one, you'll put it on the other. That is 1% transfer is taking place. That is the meaning of that. Yes, any one of you have got it? Anyone have got you the value of charge? The value of Q? Yes, Q1 and Q2. Huh? Okay, without E, what is the answer? 20? 10 power 29.
The charge is
The
neutral charge is 29 E, right? So you just subtract and add 1%.
1% of 29 E, yes. Yeah. That is for 1 atom. This is 1 gram.
Wait, can I do something? Is the answer very big? Or
Tell. Big hai. It is big. 1 coulomb is a very big charge.
No, this is a very simple. Because I didn't do anything like that. I just way different.
So what you have got? Maybe wrong, maybe right. What's the problem?
Got like something having to find, I have to calculate one more.
Okay, that value into 1 by 63.
Calculate.
You tell me the answer. Yes, Harsh.
Sir, is it just one? Is it 54?
54 into 10 power 5. No, it is not. Anyone who has got the answer? Yes, Sai Shriya.
No, sir.
Sultan?
Yes, I'm still solving.
I think that you will take too much time. So number of atoms in 1 gram will be how much? Number of moles multiplied by the Avogadro number, right? Number of mole will be 1 gram divided by 63.54. That is the number of mole multiplied by Avogadro number. That is the number of atoms. Total nuclear charge will be multiplied by, as you say, 29e. Correct? But 29e will be multiplied with the number of atoms. Is that clear? And the charge is what? 1% of the total charge. It means 1 by 100 of this value of charge will be the amount of charge held by the sphere. That will be 4.298 into 10 power 2. And the question says that the separation between the two charges is 1 meters. So in the formula kq square by r square will become 1. K is 9 to 10 power 9. And this square will be something 16 into 10 power 4, right? That will be approximately 166.255 into 10 power 13. How much? Yes. What is difficult in this?
Would you reshare it then?
Huh?
So the way I did the question is like the same way, but then the answer I'm getting it's 4.3 something. I'm not getting to.
For the charge?
Yeah, for the charge.
Yeah, close to 4.3, not a problem. It is 4.298 into 10 power 2. If you are getting 4.3, it's okay.
So, this is the charge is still 1% total, both the states.
The sphere is holding certain positive charge and certain negative charge, right? That is 1% extracted from one sphere and put on the other sphere. So of course the electron will be extracted from one, put on the other.
So that the transfer is 1%.
Yes.
So won't there be Q1 and Q2?
Won't that be?
One will be having less and one will be having more. Because
Why less and why more?
No, because see, from one charge, from one sphere,
If I'm removing 10 electrons,
That charge is different.
then that will be 10 unit of positive charge, and on which I'm putting that will be 10 unit of negative charge. How they will be different? Okay, any problem is there? So I hope the Coulomb's law in the vector form is still in your mind. Yes? Can I safely presume that?
Yes, sir.
Okay. Now focus on this question. Next question. Can we move ahead? Okay. There are 8 identical charges which are placed at the vertices of a cube of side 1 meter. We have to find force on any one of the charge due to the rest. The solution I have taken, in that I have considered the net force on the charge 6. Okay. So there are 6 charges. Do you see it? One is at the corner number 1, that is 0, 0, 0. Other is at corner number 2, that is 1, 0, 0, because it is on the x-axis. Do you understand it? The third charge is here, that is 1, 1, 0. Can you see it? The fourth charge is here on the y-axis, that is 1, 0, 1, 0. The fifth charge is here, that is 0, 1, 1. This is z-axis, charge number 8, that is 0, 0, 1. This is charge number 7, that is 1, 0, 1. You can see the diagram magnified here. The solution I have made, in that I have considered the net charge on the corner 6. But in the exam, they can ask on any of them. So let me remind to you how the force is found. F21 is what? K of Q1, Q2, because all the charges are identical. So Q1, Q2 will become Q square into R2 minus R1 in the vector form, divided by modulus of R2 minus R1 cube. Is it clear how we have to proceed? Now you can start. So for all the forces, R2 is going to be I plus J plus K, because I am considering the force at the corner number 6. Is that clear? So force due to charge number 1, for that R1 will be what? 0. And force between charge number 1 and 6, R2 will be what? I plus J plus K. Do you understand it? How to proceed? Similarly, if I'm talking about charge between 2 and 6, R2 will remain the same. R1 will become now what? I. Do you understand it? If I'm talking about charge at corner 3, R1 will become what? I plus J. If I'm talking about charge at point number 4, R1 will become what? J. If I'm talking about charge at point 5, it will become J plus K. Do you understand how to proceed? So please solve it.
Charge is Q.
How much?
Q charge.
All corners are holding Q charge. Distance is 1. That is why we can say 1, 1 for the charge number 6. Yes. Question: all the corners are holding the charge Q. The side of the cube is 1 meter. So can you tell me what is the value of F61? KQ square into root 3Q. Okay. What will be F62? KQ square into, very good, एकदम अच्छा सोच रहे हो आप लोग, divided by root 2Q. Okay. What will be F63? Excellent. Divided by root of 1Q. What will be F64? KQ square into, very good, divided by root 2. So all of you are getting these results? F61, I'm writing R2 as I plus J plus K, R1 as 0. For F62, R2 is I plus J plus K, R1 is I cap. For F63, R2 is again I plus J plus K, and R1 is I plus J. Is it clear? F64, it is I plus J plus K minus of J. All of you are getting these results? Now you have to find F65, F67 and F68. And then you have to add all the forces to find the value of F6 net. So the force will have all the three components.
Yes.
Are the three components coming same or different?
Same.
Same. Very good. What are the three components of force?
Yeah, I
Oh yeah, yeah.
Yes. What will be Fx? KQ square into? See this root 3 cube comes only once, right? So it will be 1 by 3 root 3, correct? Root 2 cube will come twice. So 2 divided by 2 root 2, right? And 1 will come only once. So it will be 1 by 3 root 3 plus 2 by 2 root 2 plus 1. That will also be F5, that will also be Fz. If I want to find the net force in the scalar form, then it will be KQ square root 3 into 1 by 3 root 3 plus 2 by 2 root 2 plus 1. Is it clear?
Yes.
And it fx, fy, fz are equal means it is symmetrical on the diagonal, main diagonal of the particle, right? In the similar manner, if you have the basic idea clear in your mind, any pair of charge they say, you will immediately answer it, right? So is the Coulomb's law in the vector form properly fitted in your mind? Or should I use another hammer to put it there in place? Or this is sufficient? Yes, online students?
Yes, sir.
Is it properly fitted?
Yes, sir.
Yes.
So any corner, anywhere, that is why I gave directly the three-dimensional question. Formula I gave for 2D, so that that diagram you can understand. But any type of system, right? Now, there is nothing like unit vector I have to use. In the textbooks, if you see, they write the unit vector. But there's no point. I have 1 minute time, right? So I need a method that will directly take me to the correct option. Is that clear or not? Right? So I have to only look for two things. One, where the charge Q2 is present. Second thing, where the charge Q1 is present. If I know their position vector, end of the story. Right? I have to write R2 minus R1 in the numerator. Once I evaluate it, I have to take the modulus and cube of that I have to put in the denominator. That's it. Okay? So this is how the net result can be written. F6 net will be I, J and K. All will have the same components. Okay? Anyone having any difficulty? Okay. Now, so far we have used Coulomb's law for a point charge. But it is possible that the charge is distributed as a continuous distribution, right? Suppose the charge is held by this rod, right? So I cannot say that the charge is present at a specific point A or at a specific point B. The charge is present everywhere between point A and B of the rod. Okay. So there are three types of charge density. One is the linear charge density. When we assume charge is distributed along a line, there can be surface charge density when it is distributed over a area, or it can be volume charge density when it is distributed over a. Okay. Linear charge density is charge per unit length. It is represented by the symbol lambda, right? And lambda will be Q by L. If I know the total charge and I know the total length. For a rod, length is L, charge is Q. So lambda will be what? Q divided by L. Okay. For a circular ring, in the similar manner, if the radius is R, it will be Q by L. The total length of the ring will be 2 pi R. So it can be written as Q by 2 pi R. Correct? Any difficulties there? And if I have extracted a small element, then I have to consider the charge of that small element. So if that small element is length dl, then the charge held by it is dq. Lambda can be written as dq by dl. What will be its SI unit? Coulomb per meter. What will be its dimension? L minus 1, m0, I1, T1. I1, T1 will be nothing but the Coulomb. I hope you understand it. Divided by the length, so it will be L minus 1. Any problem? If it is distributed over the area, we use the symbol sigma to represent it. It is charge per unit area. Sigma is Q divided by A. For a disk, radius is R, charge is Q. So what will be the area? Pi r square. So it will be Q by pi r square. If I have considered a small element, then I have to consider the area of that small element. So if the small element is having an area of dA, holding a charge dq, then sigma will be dq by dA. Its unit will be what? Coulomb per meter square. Dimension will be what? L minus 2 m0 I1 T1. Any problem is there? The charge can also be distributed over the volume. Symbol is rho. A sphere will have a volume. So its radius is r, then the volume will be 4 by 3 pi r cube. So rho will be q divided by 4 by 3 pi r cube. If I have considered a small element, then I consider the volume of that small element and what is the corresponding charge held by it. So it can be written as dq by dt. Okay. Unit will be what? Coulomb per meter cube. Dimension will be what? L minus 3 m0 I1 T1. Is that clear? So there are different systems. If I have a rod, then it will be linear charge density. Lambda will be q by L. Unit will be Coulomb per meter. Dimension will be L minus 1 m0 I1 T1. The formula lambda will be q by L. And general formula is dq by dl. Is that clear? For a surface charge density, the example can be a disk. The unit will be Coulomb per meter square. Dimension, formula, general formula. We can consider a sphere for the three-dimensional system. Any difficulty? Difficulty will come when we have to take the element. So what is the symbol for surface charge density? Which option is correct? Excellent. The unit of linear charge density is how much? The dimension of volume charge density will be how much? Any problem? The charge density is what at the sharply curved surface than the flat surface? It is maximum because the area is less, then the charge density will be maximum. Do you see this diagram here? What do we notice? There is a thin wire holding a charge of Q and a radius R in the form of a ring having a charge Q naught placed at the center. So the circumference is holding a charge of Q and at the center we are holding a charge of Q naught. Naturally there will be a force of repulsion. Correct? So there are two ways to solve this question. One method is known as the virtual work method. Right? First I will tell you the virtual work method. Virtual work method is nothing new for you. You have already used it for finding the excess pressure in the surface tension. You remember it? Okay, I will explain it to you. We imagine that this is a circular disc. Okay? Because there is a charge at the center and there is charge distributed over its circumference, so there will be a force of repulsion. That force of repulsion will try to expand it. What it will try to expand? It will try to expand the whole circular ring. Correct? Right? But the force will not be acting along the circumference. Force will be acting in which direction? It will be acting in the radial direction. So, if the repulsive force is able to do the work will be done in the radial direction. Do you understand? So, the repulsive force multiplied by a small virtual displacement in the radial direction will try to expand this ring. Okay? But is this ring going to expand? No. Because the question says, find the excess tension or the increment of force in the... So there will be a force that will act along the circumference. That is the force of tension. That is what is shown in the second cross-sectional diagram here. Do you notice it? Along the tangent, there is a force of tension T. And this force of tension T is actually acting along the circumference. So this will try to contract it, right? So the force of tension T into dc, C represents the circumference, will be equal to integral of df dr. Why I am saying df? Because if I consider the charge q naught here, at a given instant of time, I can consider only a small element of charge here on which the force is acting in the radially outward direction. that force will actually be dF. Do you understand it, what I'm trying to say? Yes. Now that dF is constant for all the elements. So this dr can be taken outside of the integration. Okay. This is a very general method. If you pay attention to it, many of the most difficult questions of physics, the solution which you will see on the internet will be having half page, 1 page, so much solution. But the virtual work method is a very direct method, to the point method. It is not mentioned in the syllabus anywhere. Do you understand it? But it is used in the backhand. Do you understand it? Right? So if you are smart, you understand this method, and this method I will tell you in every part of physics, questions will be there. Even for free body diagrams, this virtual method will work. Otherwise, if you try to draw the free body diagram, it will require at least 7 to 10 minutes to solve the question. If you are using the virtual work, 1 minute is sufficient to kill. Okay? The concept will be used in hydrostatics, as I told to you, the pressure concept. The concept will be used in gravitation. The concept will be used in magnetism. At so many places, the same small, very small concept is used. That concept is what I am telling you here. So what is happening? The dF, that is the force on the small element that is in the repulsive, in the radially outward direction, that is constant for all the elements. So this dr can be taken out. It will cause the same displacement in all the elements in the radial direction. So it can be written as dr into integral of df. What is integral of df? It is nothing but k q q naught by r square. Do you understand? Abhi aaya bache. On the left hand side, c represents circumference. Now circumference is 2 pi r. So dc will be what? 2 pi into dr. So on the left hand side, we write t into 2 pi into dr. On the right hand side, we write dr into k q q naught by r square. This dr will be cancelled. Only this 2 pi is to be shifted here, and we get the answer. What is the value of t? K q q naught by 2 pi r square. Do you understand how this method was used here? So there will be many situations where this method can be used. What we are doing, we are trying to imagine the system is in equilibrium, but it is under the equilibrium of two forces. One force is the force of electrostatic repulsion, which is acting in the radial direction. Other is that is acting along dr. Is it clearly visible to you? Similar in other cases also, like in the case of hydrostatics. If I'm talking about the excess pressure in a soap bubble or in a air bubble, in that case also, there is one force, that is the force of pressure, that acts in the radial direction, that tries to expand it. But because of surface tension, it tries to contract it. But the surface tension is tangential. Do you understand it? The surface tension is responsible for the contraction of the surface area. Do you understand the relation? Yes. So there
Yes,
we
sir.
will have pressure into area into dr on one side, and on other side surface tension into the change of the area, dA. Do you understand? Area of a sphere is 4 pi r square. So dA will be what? 4 pi into 2r dr. Do you understand? When we simplify, we get T is equal to 2T by R. End of the story. Okay, there will be similar questions in rotational motion also. Many places you will find. Okay, I have seen the solutions there. Whenever the question is asked, the solution that is provided is a very big solution. They put all the different ideas into it, but it is only a two-line solution. Virtual work done by one force is equal to virtual work done by the other force. That's it. That's all we have to do. Is it clear? So do you understand in this context? Very good. You can write it. हाँ बच्चे, हाँ 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 बच्चे, हाँ हाँ हाँ. But for integration, we have to do one by one. First, we consider the constant dr that we take out, and then we integrate df to find kq1, q2 by r. Yes, have you written it? Yes, sir. Virtual work under the force, because it is in equilibrium. Generally, we study equilibrium as the equilibrium of force. Net force is zero, net torque is zero. But the virtual work gives us the liberty to equate the two works. So this method, all of you understood? Okay, let us see the direct method, that is the calculus method. So you can see that the tension is along the tangent, right? So its component will be t cos theta and t sin theta. So if the total angle is considered to be d phi, then its components will be t sin d phi by 2, t sin d phi by 2. That will be acting in the radially inward direction. And the repulsive force will be acting in the radially outward direction. Is that clear? And the two forces, the net force is 0. So we can say that 2t into sine d phi by 2 minus k dq q naught by r square, that is dq is a charge on the small element, is equal to dm into 0, because there is no acceleration in the radial direction, right? It is also possible that they introduce that there is a collapsing of the circle, there is expansion of the circle. In that case, that factor will come here, the rate at which it is increasing or decreasing its size. But anyway, when the angle is small, what we can say? Sine theta is equal to theta. So sine d phi by 2 will be d phi by 2. So on the left hand side, we can write 2t into d phi by 2. On the right hand side, we can write dq as lambda into dx. Right? So this 2 and this 2 will get cancelled. This will be t into d phi. On the right hand side, it will be k q1 q2 by r square. That dx itself will be r into d phi. Can you understand it? So in terms of lambda, we can write like this. Or if I expand, lambda is equal to q by 2 pi r, then that 2 pi will come in the denominator. Do you understand it? Okay, this will be r.
So how did we start with that?
Same, the equilibrium of the forces. The equilibrium equation that you see here. Okay, do you understand?
Which direction is d and d?
Towards the radially inward direction. And the repulsive force is radially outward direction. Yes, is there any problem to anyone?
So in the previous equation, where did 4 pi go?
So that is there with lambda. What you are asking?
No, I didn't understand how you got it first.
Here?
No, from the previous page to this page.
This is this page only. These are the two forces.
Different direction.
This is the standard method. This is method number 2.
Okay.
Clear? Can we move ahead? Now, if there is a system of multiple charges, then what will happen? We consider the force between any one charge. Suppose We consider force on charge Q1 due to Q2, and we denote it by F12. Similarly, the force on Q1 due to Q3, we call it F13. And when we add the forces, what do we get? We get the net force. Is that clear? The net force will be given by what? The vector sum of the forces. Any problem? Here it is written in terms of the unit vector, right? Okay. So try to read this question. A charge Q1 exerts some force on a second charge Q2. If third charge Q3 is brought near the force exerted by Q1 on Q2, what will happen? Will it decrease? Will it increase? It will remain unchanged. Yes, that is called the superposition principle. The force between the two charges remains unchanged whether any other charge is present or not. Two charges are placed at a distance apart. If a glass slab is introduced between them, then what will happen to the force? You remember we discussed about it? We said that F is equal to Q1 Q2 by 4 pi epsilon naught into R minus T plus T root K the whole square. The glass is a dielectric medium. So what it will do? So which option will be correct? Is it clear? Any difficulty? No? Now let us move to the next question. There are two positive charges Q1 and Q2, and they are located at points with the position vectors R1 and R2. I have to find a negative charge Q3 and its position vector R3 so that the system will be in the state of equilibrium. If you want, you can write the question. We are talking about something like this situation. There is a charge Q1, there is a charge Q2, and there is a charge Q3. This is the diagram. They are meeting at this point. Charge Q1, charge Q2, charge Q3. The position of Q1 is R1. The position of Q2 is R2. The position of Q3 is R3. Because Q3 is a negative charge, so Q1 will attract it in this direction, the direction of R1 minus R3, and Q2 will attract it in this direction, R2 minus R3. The net force on Q3 will be 0. So from that, try to find the value of a R3 vector. Right. Yes, any problems there? Have you found anything? Yes, anyone can tell me what is the value of R3? Anybody will tell the answer? Any online student wants to tell the answer? Yes, Isha? Okay. I hope you have done sufficient work. So the net force on the charge Q3 will be 0. Yes. So the force on 1 charge 3 due to 2 plus force on charge 3 due to 1 will be, sum will be 0. I can shift this term to the right side. Correct? Q3 and Q3, K, Q3 will be cancelled. And I can write Q2 divided by root of, means R2 minus R3 the whole square will be equal to Q1 divided by mod of R1 minus R3 the whole square. Do you understand this step? Yes or no?
Yes, sir.
Because the direction of R2 minus R3 is same as the opposite to the direction of R1 minus R3. Is that clear? And any vector A minus B square is equal to its modulus square.
So, but then
I
over
hope you
here, we're
understand.
just taking the mag.
Yes, tell me. Can you please repeat?
Over here, we're just taking the magnitude, right?
Yes. But we know that for any vector, the magnitude square is equal to the vector itself square. Do you understand it or not? If I write vector A square, it is nothing but the mod of vector A square. Do you understand it? Yes or no? Now, when I take the square root, it will be Q2 into R1 minus R3 will be minus Q1 into R2 minus R3 because I have to take care of the direction also. R1 minus R3 and R2 minus R3, they are opposite to each other. Of course, when we take the square root, plus minus we have to consider, but here we consider with the minus sign. So this Q2 R1 and this minus Q1 R2, if I will shift here, it will be added. Can you understand it? And this is Q1 R3, and from that side, root Q2 R3. R3 can be taken common, and this is the value of R3. Look at it carefully. Okay. If there is any difficulty, please ask. बोलो बोलो बच्चे, दिक्कत हो रही है पूछो, क्योंकि ये नया आप सीख रहे हो अभी. हाँ, आप ही बोलो, जिसका भी दिक्कत है, नॉट अ प्रॉब्लम. Q3. First, I am considering Q3, not and not anything else.
But then in the question it's written that the equilibrium is for the entire system.
अभी आ रहे हैं बच्चे. Wait. Now we are talking about the. We had to find two things. We had to find Q3 and R3. Just now we have found only R3 because Q3 is cancelled.
The negative is due to the opposite direction.
Opposite direction. That is why here I have to take the negative because I am taking the square root. Square root will give plus minus, right? So we are taking minus because R1 minus R3 vector and R2 minus R3 vector, they are in the opposite direction. That is why I have to consider the negative sign. I'll write it for equilibrium of Q3 so that it's clear. Okay, this is for the equilibrium of Q3. Yes, any difficulties there? Now the target is to find the value of Q3. For that, we can consider the equilibrium of either charge Q1 or Q2. So try to see in the diagram. For equilibrium of Q1, situation will be like this. Q1 will be repelled by Q2 in this direction. It will be attracted by Q3 in this direction. The sum of these two forces will again be 0. In the similar manner, we have to write as we had written earlier. And in the question itself, we had specified that Q1 and Q2 are positive and Q3 is negative. So when we have to relate the value of Q3, it has to have a negative sign. Do you understand? F12 plus F13 will be 0. For F12, we can write K Q1 Q2 into R2 minus R1 by R2 minus R1 the whole cube. And F13 will write K Q1 Q3 into R3 minus R1 divided by R3 minus R1 the whole cube equal to 0. Now I'll shift this term on the other side. And we know that R2 minus R1 by mod of R2 minus R1 is equal to minus of R3 minus R1 divided by R3 minus R1. So Q3 will have a negative sign because you see the denominator here are the magnitudes, right? So Q3 and Q2 should have the opposite sign. That is why we have a minus sign here. The value of R3 we have already evaluated. That value of R3 now we have to put and we have to get. Yes, tell the value. Yes, बताओ बच्चे.
Minus Q2 R3 vector plus Q2
R1 and R2 is still there in the final result. Yes, tell the answer.
Yeah, this should okay, this should
So what
Yes, anyone will tell me what is the value of Q3?
I think it's cancelled.
Krishna, Nilesh, Lodhia, Rejoice.
Still do. So,
Amita, Shaji, yes.
divided by what Q1 square and taking it out of square, so it will become Q1. So Q1 is equal to
बोलो बच्चे आंसर बताओ. What is the value of Q3? ध्यान दो. Pay your attention. This is the time for you to learn, understand. This is not the time for you to waste. Yes, बोलो बच्चे.
Root Q3 now.
Why root Q3?
the square, because that's, but how can you get roots from there? Should be we're not messing with something.
Okay, you tell the answer. Not that.
Oh yeah, third root.
Yeah, then
बोलो बच्चे सही होगा या गलत होगा. कोशिश तो करोगे.
ऐसे minus Q2 Q1 divided by root of Q1.
no, anything.
बहुत नजदीक है. Very close. Yes. What you have said Q3 is equal to minus Q1 Q2 divided by root Q1 plus root Q2. You are so close.
It's not minus Q. It's
So close.
plus Q.
Now think dimensionally you are wrong here. In the numerator I have Coulomb square, right? Charge into charge.
Yeah. Oh, the whole square. The denominator, the whole square.
Yes. That is the answer. Very good. So this was the value of R3, you remember it? So in place of R1 minus R3, we can write like this, right? So it will be root Q1 into R1 vector plus root Q2 into R1 vector. Is that clear? This minus sign, root Q1 R2 vector minus of root Q2 R1 vector. This root Q2 R1 vector, root Q2 R1 vector will be cancelled. And this, if I take root Q1 common, I will get R1 minus R2 the whole square. That will cancel the denominator here. And root Q1 square will become Q1. That will come here. Is that clear?
Sorry.
So could you go back to the previous slide? I want to check something. Yeah. Could you show the next slide?
No problem.
So, but how does the minus sign still remain?
Because you remember initially when we talked about the charges, the body with Q1 and Q2 are considered to be positive charges, and Q3 is considered to be negative charge. Do you remember it?
Oh, okay, I missed out on that detail.
So initially, when I talk about the equilibrium of Q3, whether Q3 is positive or negative, it will be in equilibrium. But because I had considered Q3 as negative, so the force due to Q1 was attractive. Do you remember it?
Yeah.
If I had considered Q1 to be positive, then the whole system will not be in equilibrium. Do you understand it?
Yes, sir.
So I have considered Q1 to be positive, Q2 to be positive. That is why it is mentioned in the question, right? So that you are guided in that direction. You choose the final answer correctly.
Yes.
And Q1 is considered to be negative so that it will experience two attractive forces. Is that clear?
Yes,
and
sir,
the sum of those two
understood.
forces will be 0. But when I am talking about the equilibrium of Q1, due to charge Q2 it is repelled, but due to charge Q3 it is attracted. Again, if Q3 was positive, then both the forces F12 and F13 will be in the same direction. Then there can't be any inequilibrium. Is that clear?
Yes, sir. I forgot the minus sign, so I messed that up.
Not. Any problem, any difficulties there? Yes or no? Will it stay with you? Very. What do you see here? And what do you see here? Yes? The child is happy or sad? Why? In this example, the child can be considered to be a test charge who will experience the effect created by the source charge, that is the lion here, right? And when he is brought into the cage, as long as he remains outside the cage, he does not experience any effect, right? The cage represents what? The boundary of the electric field produced by the source charge. Do you understand it? So in the similar manner, when I'm talking about the force, that will be KQ1 Q2 by R square. And when I'm talking about the electric field intensity, how it is defined? It is defined as force upon charge. So it will be written as KQ by R square. Is it clear? Yes. Magnitude will be what? 1 by 4 pi epsilon naught into q by r square. Correct? If I have the vector form r1 and r0, then E vector can be written as kq by r1 minus r0 the whole square mod. Right? R1 is the point where the charge is kept. R0 is the point where we are trying to find the field. SI unit will be what? Newton per coulomb and volt per meter. I hope you understand it. Which type of quantity is electric field intensity? Which option is correct? Huh? Option B is correct. How electric field intensity can be represented? Option D is correct. If there are multiple charges, then what will happen? All of them will create their own field, right? So field due to the charge Q1 will be given by the vector E1. Field due to charge Q2 will be given by vector E2. And the resultant of E1 and E2 will be this. Force due to charge Q3 will be given by E3 and E3, and they will have the resultant like this. Force due to charge Q4 will be this, and the result of this will be given by this. Can you understand it? This is known as what? Superposition principle. So the net electric field will be what? The sum of the electric fields. So, which option is correct? Sure?
Independent.
Very good. This is your homework. You can try it. And which formula we have to use? I hope you understand it. KQ divided by R1 minus R0. Okay. If I have to find the vector form, then I will write R1 minus R0 in the numerator. In the denominator, I will write Q. Right? If I have to find only the magnitude, I'll use this form. Yes, all of you understand what is the question? Try to solve it.